Chromalyzer is a tool for color professionals who want to take the guesswork out of selecting color. It allows you to make objective decisions about how your colors compare to one another and how they compare to competitor colors and/or forecast colors. It allows you to look at color as a three-dimensional space. It works on importing color data that sets the absolute location of all your colors in the palette in a three-dimensional space referred to as LAB color space, showing how light the color is, how chromatic the color is, and what shade of color the color is. And so by working with color data and these various tools, we can look at color in this three-dimensional space. This allows us to do a number of different things. We can add layers of color palettes, so we can compare in this three-dimensional space two unique palettes of color. So here, if we zoom in, we have one palette of color identified as circles and another palette of color identified as squares. So we can see where one group of colors exists relative to the other group of colors and where possibly it expands that area of color space. It lets us make that comparison with a number of different detailed filters. For example, we can look at just one slice through that color space and start to see in more detail where our palette A, which are the circles, and our palette B, which are the squares, may have strengths and weaknesses. In this example, you can see that we have some colors in this gap here where palette A is not occupying the space at all. It allows us to make comparisons of how similar colors are from multiple palettes, and so palette A compared to palette B, if we wish to look at similarity as being defined as 2 delta E color units, this function will compare these two palettes and give us the result and show exactly which colors are similar within the group. Similarly, we can say which colors are unique within the group. And so immediately it calculates and will allow us to see where we have colors that are unique and where our competitor has colors that are unique. And all of these can be filtered or put through the same filters to get detailed information. It allows us to generate new colors in between existing colors. Here we can interpolate through two actual colors, and we can get color data that identifies these new colors that we may want in our palette visually, data in a way that we can use to manufacture those colors. We can lay out our colors in a grid form as well as in a three-dimensional form, and so we can simulate how our colors will appear in a two-dimensional array with multiple different ways of organizing the colors such that we can speed up the what-if process of doing color presentations.